chapter 10.1, chapter 10.2 from the book. That's the rest of the book that we're going to be doing. In this sections, however, it's really nothing for AP, okay? So, but it will be on my test, and you will need it for your future math courses or physics courses or whatever courses. Okay, so it's really, I'd be doing you a disservice if we didn't cover those here at the high school level before you went on somewhere. Okay, so we're going to introduce vectors, and then tomorrow we're going to do it in 3D, and then, so then what was that? Thursday we'll be doing speed and the acceleration, magnitude, vectors, all of those. For the AP won't be until that day, okay? So we'll have speed, Eulers, and logistic notes. That will be the last 3 AP topics. And then it's review time, okay? Okay, so vectors. What's your vector, Victor? So a vector has to have 2 things. It has to have direction and magnitude, right? Has to have 2 things. So if you think about velocity, force, displacement, they all have a magnitude. What does magnitude mean, Darius? Any idea? Joyce, magnitude? How big it is, yeah? The quantity, the amount, the length, okay? So if you have a vector, it's going to be the length, okay? How big it is. Could that ever be negative? Magnitude cannot be negative, because it's like a whole length. Be saying a side of a triangle is -2. It's a length. It has to be positive, okay? The direction be negative. Okay, so for some reason it's not quite working in here, so I have to come right here to do it for you. Yes. You really have to. Why isn't it? I just took all the way up. Hold on, let me try again. I love this cookie. Like, it makes my life so good. Why isn't it? Because I have my headphones up. I know, I love that. So I think my 5-year-old, just 5-year-old daughter knows what a vector is.
Oh, I bet you love that.
Okay, so vectors need what? Direction, arrows, right? The arrows and magnitude. Alright, oh yeah, that's where it was supposed to be. Okay, so when you have this vector going on, you have an initial point and a terminal point, and you draw your line through them. Whatever the terminal point is at the end, you can put an arrow. I always put a half arrow like this when I go to draw vectors. And that lets me know it's a vector, not a ray. Okay? And that's how I was kind of taught when I first learned it. So I always do like little half arrows, so I know the direction that it's moving, but I know it's not going to continue like a ray. Does that make sense? Okay, when you want to write what this vector is, so like let's say this was the point, give me a point. 7, I heard 5, and what?
1, 0.
1, 0. So if I had that as my terminal point and my initial point, to find the vector components going on, I do terminal minus initial. So what would your x be? 6. What would your y be? 5. And those would be the components of that vector. Okay, so it's going to be terminal minus initial. The magnitude is denoted with the 2 bars. It's not the absolute of the absolute value, but it's magnitude. Magnitude means what? The amount or the length going on. Make sure you put a plus here for me. Okay. So if I want to know the length from here to here, all I'm going to do is use my distance formula, which kind of roots back from the Pythagorean theorem, yes. So I could just use this distance formula. So if I found those components already, kind of like this guy, right? Oops. When I went to go find the components already, that was already the change of x. This was already the change of y. Agreed? So when I go look here, if this is the change of x, I've already got it, so I could just put that number. If this is the change of y, I've already got it, so I can just put that number. Don't continue to find the change of x and the change of y and do all of that unnecessary calculation. Okay? Alright, a directed line segment that have the same length and the same direction are going to be equivalent. So in this case, you can see all of these guys have the same length going on, and they're all parallel to each other, going the same direction. And I would just do it one line. Anyway, so those are all equivalent. So tell your group members what 2 things you have to do to be equivalent vectors. Everybody got it? Okay. So let's look here, and we have some points A through D. We want to show that vector u, which is AB, and vector v, which is CD, are equal. So Shane, what 2 things do I have to show for equivalent?
They have the same direction.
Direction. How am I going to show they have the same direction? Slope. Good, Michael. The slopes are the same. And the magnitude, we just find the length. What can we use? Distance formula. Okay? So we need to do that for vector u and vector v. Isn't it fun just to say vector now? Oh yeah. Okay. So see if you can find both of those things. Let's find maybe the slope first. Is that cool? So let's see. The slope for vector u, change in y over change of x would be what? 4 over 3. Slope for vector v, 6 minus 2 over negative 1 minus 4 over 3. They have the same direction. Now I need U then. Change in Y, change of X. So this would be what? 3 squared plus 4 squared, which equals 5. And the magnitude for B, we've already done the change, right? So if you want to do it again, you can. Which equals 5. Check. Check. No, I just did. Okay. So are these equivalent? Yes. Okay. Okay, component form. You all ready for this? Okay, so if you've been seeing us in the hallway today, you can now be part of the cool kid crowd. I got a little symbol in calc BC. Alright, you do it? Woo!
Just like it's
Okay, so make your peace signs. Flip them over. Go in. Alright, so what you have to have are in your vectors are basically instead of parentheses or braces or whatever, you have these sideways guys like this. Okay, to write your vectors. Okay. So this is the component form of a vector. So if I say component form, I want you guys to flash it to me. Alright. Oh, Darius. You're just not cool enough. Peer pressure. Darius, let's see it. Conform. Come on, Darius.
I honestly don't care today.
Come on, Darius. Peer pressure, Darius. Come on, Darius.
Peer pressure for your teacher.
Peer pressure.
It's not peer pressure. Yeah.
Make me so sad.
Love the influence.
Alright, so basically when we did all the way back, keep going, right here, and we found this guy right here, we could say that whatever this vector was, vector AB, in component form would have been 6, 5. Okay? So what that means is like if I shifted that vector to where the very beginning point was on the origin, I would go 6, 5, and get the same vector as what we just had. Okay? Because remember, we could take the vector anywhere as long as it's still facing the same direction, the same length. So all we're doing when we do terminal minus initial is we're moving that vector to be at the origin for the starting point. Is anybody unclear what I'm saying? Okay. The 0 vector. Yeah, okay. And unit vector means that it has a magnitude of what? 1. Tell your buddies that. Did you say 1? Okay, a unit is 1, right? You do terminal minus initial. So negative 5 minus a negative 3 would be negative 2. 2 minus 4 would be negative 2.
So it has to be terminal minus initial.
Yeah. So basically, let's see, what did we need to go to? So if I took that point, negative 5, 1, 2, negative 3, 4. So we had, this was our beginning, this was our end. There's our vector, right? All we did with that vector is move it. So we got to move it over 3 and down 1, 2, 3, 4. So this will go down 1, 2, 3, 1, 2, 3, 4. Kind of like that. Does that make sense? So we're just taking this vector and moving it to where the initial starts on the origin, and whatever that point is, that's our vector. Whoa. Okay? Alright. And now finally. Brett, question? Okay. Did you guys get 2 radical 2? I would hope you would. On the AP test, never ever simplify. We'll get to that. But for me, yes. Simplify. And cost you more time. We'll go over that when we review. But for me, for math, for my sanity, yes, please. Alright, so if you've got it in this form, AB, it just basically says that your initial is at the origin, so if you wanted the slope, well, rise over run is just going to be, right, B over A. So it'd be like B minus 0 over A minus 0. Okay? A lot of this is just basic little things, but we're just covering them. Alright, find the component form of the vector B, length 6, that makes an angle of 45 degrees with a positive x-axis. Matt, what's the first thing you think to do? Yeah, first we'd read the question. Let me read. What's the first thing you think to do? So look at the axis where? Oh, perfect. That's the first thing I would do, is draw something on my paper. All right. Now we just got to think simple again. We're not polar. This is very, very simplistic, okay? So that's what I would first sketch. So, how many of you said, like something like that? Okay, that's what I would do. And this is what kind of angle? So what does that have to be? Alright. 45, 45, 90. So I don't know what that x is, and I don't know what that y is, but what do I know about x and y? They're equal to each other. Okay, so what are some ideas that I could do to go about finding x and y? Brooke, any ideas? Anything come to your mind? Think back. All your other classes. Sure. Sign what? Like, what's this? We we don't know, so you want to call it xy. So that would be your x. That would be your y. That's what we're trying to solve for. Uh-huh. Good. And then could you solve for y? Okay, and then, so you could solve for y, and y is equal to x. That's one way you could keep going. Who thought of something else? Joyce? The distance formula? To find what x and y would be, because we're trying to find the component form. So I need to find what that terminal point is, so I can put it like this. Okay. Okay. So like x squared plus y squared equals 6 squared. And if they're the same, you could basically make it what? 2x squared equals... Alright, so either way you'd like, go ahead and solve for x and y. You're back there on this. 45 is pi over what? Pi over 4. So it'd be what? Oh, for your final answer. I thought you were going to say. Your final answer is, yep, 3 radical 2, 3 radical 2. You're only going to be wanting the positive.
Hey, this is Russ. Shouldn't the x and y shouldn't it be on the b thingy?
Well, I was just saying that point.
Okay.
X, Y. If we wanted to talk about the vector, then we would, yes. Okay? Okay. Now you're ready to blow your mind. I don't know why AP writes their vectors with parentheses. I do not know why. I've never seen that anywhere else in the AP exam. Okay? I want you to do this for your vectors, but when you get to AP and it says find the vector and all you see are parentheses in the answers, it's meaning the vector. Okay? But that is something I will not conform to. It won't ever be on a free response. No, they will count. Yeah, it might actually. Yeah, sorry, it will be on a free response, actually. So, I retract what I just say. I was thinking of a different type of question. It doesn't matter which way you put it. They'll accept that just fine. So you can make me proud in your head like that, okay? So, is that what was supposed to overfind? Are you ready? Yeah, I know. Okay. Okay, so now we're going to talk about vector operations, but I'm going to show you with geometry what this means. You don't have to always do the geometry, but I think it's really good to see what it's doing to the vectors. So if I was to go and do vector operation, all we have to do is add the first two together and add those two together to get your new vector. Okay, so it's really, really basic. But what you're actually doing, if I take A as my first, okay, so A plus B, so I'm going to take A to be my starting point. So I take that guy, and then I'm going to move B right here where this end is right there, okay? So it's just kind of continuing the vector, connect the dots, kind of. So I'm going to move that. I got to keep it parallel, same length, so it looks something like that. Is that okay? So your new vector, A plus B, is from the very start to the very end. There's your new vector. That's a little bit straighter. So that's how you would get A plus B. Yes?
This may be a dumb question, may not, I don't know, but if you move, like when you're moving the B vector to be with the A vector, does it matter which point you go to, like the...
Yes.
Okay.
It has to be at the end of A.
Okay, so like the arrow thing.
Uh-huh.
Okay.
This word always says tail and tail.
Yes. Yes.
How is it A plus B equals two vectors?
Yes, so this would be a vector, A plus B.
No, I'm saying like the two angles that make up, not the angles, but the arrows that make up like A plus B. Like the other 5.
Right. This arrow?
Like, yeah. Like, not the one you drew.
This is A.
Yeah, wouldn't those
That's
be
B.
longer than the one that you just drew?
I don't think I'm getting what you mean.
Like,
You're talking about like if you were to
He's talking about like
so
lines.
it had the same
Like the lines.
like I'm talking about the not the line she just drew, but like the 2 lines at the end there.
The two vectors that you just drew that are next to the A plus B, those two
Those be longer than the one than the actual A plus.
Combined? Yes. Yeah.
So why like A plus B is
Well, you could try it out with some numbers if you want to see. But A plus B doesn't mean that you're going to take and make it continue in the same direction. It's because you're changing some of the direction as you start moving. Because this B isn't in the same direction. It'd be the same length if they were moving in the same direction. So like if I did A plus A, and like something like that, well now I have exactly the same length of like A plus the magnitude of A would be A plus A magnitude. But since here you're changing directions, you're not going in that same line, you're going to lose out on some of the length. Okay? Alright, when you have like this guy, just a scalar, so any kind of number, then you can distribute it in. And all that's going to do is either elongate or shorten your vector. Okay? If you have a minus, again, you can put it in. What it means to like have a minus of u, if this was u, it just changes and goes the other way. So this would be negative u. So if I wanted to subtract, let's say that this is vector u, and we have vector v, I don't know, going like this. And we want u minus v. What's the first thing we would do? No. We have to do what to v? We'd make it go the other way. So now, that is a parallel vector v that goes that way. Now we can do the tail to tip. Okay? So this was where I started at u. This is where I ended at u. So now this is where I started for v. It's going to go right there. And I have to make that v something like that. So then the minus is going to be where I started from to where I end overall. So that little guy would be u minus v. And you guys are all really interested in this. I think it's fun. Commutative and associative laws hold true. If you remember those from algebra. So, in your groups, do this one. Go. Oh yeah.
I'm stuck in your head all night. It's always so beautiful. So much. Oh, also actually, I saw
So do it from the way you talk about vector.
I thought it through us first.
And then you thought we could talk about
Vector.
Open up the answer so you can check yourself.
Check yourself. Check yourself.
okay, so and you set it up, you can just multiply one by 2 and then vector multiply by both.
Right. So 2 goes into both of those. magnitudes cannot be negative, okay? But both ways are fine. Okay, so let's say you wanted to find a unit vector, which means what, Rachel? What's a unit vector? Length of 1. So let's say you wanted to find a unit vector in the same direction of any vector. Okay, so you want to find it. All you're going to do is take your vector and divide by what? The magnitude. That's all you do. Okay? So if you want to make your vector go in the same direction but only be 1 unit, so basically if you had this vector like this, and you wanted to make it only be 1 unit, okay, like all of these were units or something, then you take the whole vector and divide by its magnitude to get back to 1. Yes.
What is the importance of units in calculus?
Of unit vectors?
No, just sort of units. Like 4 the previous one was like, I don't know, for 2. Like, is that important in calculus at all?
Oh, if it's given, yeah.
If it's not given.
No.
Physics.
Yeah. So, let's take this vector and make it into a unit vector, but going the same direction as this vector. Same vector, it's really fun. Alright. So, what's the first thing I have to find of this vector? The magnitude. What do you get the magnitude? Radical 45. Okay? Yes? So now if I want to find the unit vector, I'm going to take 1 over 3 radical 5 and distribute it into your vector. So you're basically dividing each component by its magnitude. You say huzzah. Sure.
I don't know person.
I think we should. I would have Rachel even if you didn't say that. So now there is your unit vector in the same direction. It says, and verify that it has a length of 1. Is it really a unit vector? We'll go do that now. Well, this is such hard math, Rose. Don't make me do it. So I'm going to actually use this one.
This is a healing schizophrenia. Talking to yourself is admitting that you have a problem first.
Yeah. Was that you? Are you admitting something to us?
Have you seen a video of what schizophrenia is like?
No.
It's a
Yeah, we had to listen to that.
Derek, you get this? Alright. Alright, deep breath in. Deep breath out. Let's pop. Ready, cold, deep breath in. Deep breath out. Alright, here we go. So now you may have seen this in books that you've had, like physics or whatever, but they... You ready? Show me component form. Component form, right? Okay. So we got component form. Hold on, I can do this. trying to get it out. Alright, sorry. Okay. So, linear combination or standard form is next. What's next, Brooke? What's next? Got component form. Show me component form. Okay. Standard form, also known as a good linear combination. In order to do that, we're going to have standard unit vectors. Standard unit vectors are going to be I and J. So basically, if you have this x and y axis, and you go out one unit in the x direction, and have this vector right here, we're going to call this vector I. This is a different I. See how I made it a vector? Okay, so this vector would be 1, 0. Let's say that we went up 1 unit on the y and made my vector. This is going to be called vector j, and I don't do the dots with the vector. I just make the vectors my dots. And this would be 0, 1. Yes?
So, like, those aren't always the value of I and J, are they?
Yes. In two-dimensional, yes.
Those are always the value.
Yes. In two-dimensional. Tomorrow we're going to do three-dimensional.
Oh, yeah.
Okay. So yes, in two-dimensional. Okay. So, vector v, this is what form? Correct? Let's pick on birthday. This is what form that I just boxed? Component form. This down here is an equivalent statement, but it is now going to be in standard form. Okay? So how did we get from here to here? Well, one, you can just put your v sub 1's with I, v sub 2's with j. That's one way. Okay? But again, where did all of that come from? So we're going to start and say, well, this v sub 1, v sub 2 would be v sub 1, 0, 0, v sub 2. Do you agree if I put those together, I would get v sub 1, v sub 2. So then I'm going to factor out the v's. So I'm going to factor out a v sub 1 from the first guy, and factor out a v sub 2 from the second guy. Right? And then this guy is just what? Vector I. This guy is vector j, and that's where we come to here. Yes?
So are I and J always in terms of water, maybe like 5, 0, 0,
No,
5?
they're always like this. Okay? Alright. So, let's look here. It says U is going to be a unit vector with the initial point 2, negative 5, and terminal point negative 1, 3. Right? Each of the following vectors is a linear combination, and we can get to V. So let's do U first. Let's first put it in component form. And then we can do to the linear combination / standard form. Alright. Component form, Brookie. Initial minus terminal or terminal minus initial? Yes. Good. So there's the component form. So if I want to write it in the linear combination or standard form, I'm going to write it as how, Brookie? Bring down your... So, negative 3, and which one comes first, I or J? I. I is first in the alphabet, just like X comes before Y, I comes before J. So I'm going to have vector I. So it's going to be a positive or a minus. Positive with what? Vector J. There's your standard form or your linear combination. You guys try to do the same thing on number 2. That's all. Says negative 3 vector I plus 8 vector j. That's a 9. Okay, try number 2. And if you have it, I'll check you. And then see if you can do the last question after I check it. Nope.
So,
We wrote vector u. And I want you to find vector u. Vector u. So B was given as a linear combination right here. Right? If you want it into component form, what would that be? No, it's still there. Okay. Does that help? Alright, you got it? Oh, we kind of did it all together. Right? That's right. I can get 6. I forget to distribute. So you try to put i's and j's all together. That's not what we do. See right here. Your i's and j's all up. Alright, so if I was to put this up, this is how I would work at it. I would say 2 times vector u we found to be negative 3, 8. That's what we did in number 1. Minus 3 times vector v they gave us right here, so it would be 2, negative 1. Huh? Because you just bring your 2 and you negative 1. This was in linear combination, you just pull out the coefficients. So this would be negative 6, 16, plus negative 6, 3, which would be negative 12, 19. If you like, that's in component, and then you could say that that's negative 12i plus 19j. That's linear combination. If you like just working in linear combinations, great. 2 times negative 3i plus 8j minus 3 times 2i minus j. Now it's just an Algebra 1 problem of combining like terms. Did you see that? And you'll get to the same answer.
So what's your final answer?
The component form is this guy. It wanted it in linear combination, so that would be the linear combination. So you could just notate both of those. Okay? Okay, try the last one by yourself. Negative 12i plus 19 vector j. Negative 12 vector I. So on that last one, you could memorize the formula, but a better idea was maths is to just draw a picture, so you don't have to memorize another formula. Yes, that's 10.1. It's not that anything is like too difficult, it's just like vectors. It's usually very common sense. Okay. Basic algebra. I'll put up what you should get and see if you guys get that.